we see a very large potential in the future of autonomous driving, whether it's an application in form of a robot taxi or an automated freight or cargo or anything that will fly autonomously. And so we see that as a very interesting space to be in, for sure. For now, our focus is very much tailored towards autonomous driving, but that could entail many things, of course. It could be the application in the form of a robot taxi, could be autonomous delivery robots. Very interesting space that we're looking into is automated freight, cargo, trucks that drive autonomously from distribution point A to B, for example, last mile delivery. But the autonomous mobility space is much larger than anything that will drive on the road. As a drone needs to take off from a port in Antwerp, needs to fly to the port in Amsterdam with a package. Well, that drone needs to fly across several jurisdictions, whether it's sort of the member state of Belgium or a few counties that it needs to cross. And each of these regulatory bodies has their own sets of regulations and laws. And so to be able for a machine, a piece of software, to understand which laws it needs to comply to, it's very, very difficult, of course. And so we came up with the idea to start training AI to make sure that a machine understands the jurisdictions that it needs to fly over and comply. The drone needs to know and understand that in real time and needs to bypass that zone and continue its path towards the other port. Ultimately, the solution that we're providing to the engineers in the autonomous driving community is a piece of software. It's basically a product that allows engineers to tap into regulatory databases or any sort of requirements database, tying into AI, safety, security, functional safety, all of that. The AI or the LLMs that are granularly trained on this data will pick up the requirements automatically, convert them into a scenario description language, which can then be used to build your autonomous driving scenarios automatically, and on top build variations of those scenarios automatically.
Today we're at the University of Warwick to run some of the simulations that our platform creates in their 3XD simulator. Working with MFM has been a great experience for us. So in order to develop safe autonomous vehicles, we need to make sure that these vehicles behave well in every situation that they can encounter. And to ensure that, we really need to test them on like 5 billion miles of driving. That's impossible to do. It's way too expensive. It would take too long. And that's why we use simulations to test vehicles in virtual scenarios and see if they behave correctly in all those scenarios before we put them on the real roads. Working with MFM has been a great experience for us because at Deontic, most of us actually come from an AI background and we didn't have a lot of knowledge about the autonomous world. So WMG has really helped us learn more about the standards and the regulations in that world of autonomous driving, understand those better so that we can adapt our AI systems to deal with them. The people at MFM have also helped us validate the simulation files that our platform creates so that we're sure that engineers can go and use them in their own simulation platforms and run the real driving scenarios with them. What I've enjoyed most is bringing the world of AI together with the world of autonomy so that we can use AI to make sure that people can move around freely in vehicles that are safe at all times.
CAM Scale Up UK programme offers us an excellent opportunity to bring together academic research and an exciting startup. It's a really good example of how the strong research base here in the UK and the strong regulatory environment can be built upon by a visionary and exciting startup to enable engineers to accelerate the safe introduction of self-driving vehicles. The Operating Design Domain Framework allows us to work with Deontic to accurately locate keywords, structure and prioritize the language such that the scenarios they create are accurate representations of standards, regulations and customer requirements.
It came to our understanding and basically our realization that whatever we're building for the vendor community is equally important for the regulatory bodies. The regulatory body can use the GenAI tooling to understand or to identify the gaps in their regulations vis-a-vis the vendor And the vendor can use the Gen AI tooling and the large language model to integrate the existing regulations into their vehicles to bring safe vehicles to the road. I think it was Jensen Huang from NVIDIA that said the new coding language is English, which is a great, great vision. And we sort of feel the same way about using natural language to code safe autonomy into vehicles of all sorts and all kinds in the near future. So that is sort of the combination of the elements that keep us going and where we are very passionate about and very excited about.